Hi guys, in today's video we're going to look at changes in entropy, Gibbs free energy calculation, the feasibility of our reactions, looking at exothermic and endothermic reactions, limitations of our calculations, and finally an exam style question.
Changes in entropy. Well, you'll be familiar with this equation here. In our previous video on entropy, we discussed how the total entropy can be calculated by looking at the entropy change of the system and adding that to the entropy change of the surroundings. And we discussed how the entropy change of the system is the difference between the entropy in the products and the reactants. Well, the entropy change of surroundings can be calculated by doing delta H over T, where delta H you'll recognise as the enthalpy change and T is temperature in Kelvin. Now, in order for our reaction to be spontaneous, that is to happen instantaneously, the total entropy change must be positive. Now, this isn't the only factor affecting the feasibility of our spontaneous reaction. We must also look at free energy. Now, the energy freed in a reaction is known as Gibbs free energy and can be calculated with Gibbs' equation. Now, G is used to symbolise the free energy, and delta G means change in free energy. And the way we calculate this is to do delta H minus T delta S, where delta H is the enthalpy change, T is the temperature measured in Kelvin, and delta S is the entropy change of the system. Now, delta G, or the change in free energy, must be negative for a reaction to be spontaneous. So let's have a look at the feasibility of reactions using the Gibbs free energy equation. Well, here we have our Gibbs free energy equation. So if we were to have a negative value of enthalpy, a negative enthalpy change, and a positive value for entropy change of the system, you can see we'd have a negative value and we'd be taking away a positive value, making our value more negative. We'd result with a negative delta G, meaning that our reaction would be feasible because delta G is negative. If we had a positive value for delta H, as in the second row, and we took away from it a negative value, we're taking away a negative value, and a double negative gives us a positive. So we're adding a positive to our positive.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.